Hello, everyone. Thank you for joining us for today's webinar to learn more about the LYT mobility solutions. Next slide. So for today's agenda, we're going to cover a number of things. We're going to look at the state of the industry today. We're going to look at LYT's approach to preemption and transit signal priority. We're also going to take a look at some cloud-connected tech in action with a couple of case studies on emergency preemption as well as transit signal priority. And then hopefully we'll have some time at the end for questions. Please use the question feature at any time for your questions, and we will address them at the end of the presentation. We also have a quiz question that we like to put into this, and the winner will receive a gift from Stinson. So we'll move on to the introductions. My name is Sherry Rowell. I'm the Western Canadian Account Manager for Stinson ITS. We are a traffic technology company based in Vaughan, Ontario. We distribute and integrate a wide variety of traffic management hardware and software solutions. This includes industry-leading permanent traffic sensor systems, as well as temporary work zone digital traffic management technologies enabled by Internet of Things devices. Stinson ITS is part of the Ramadan Inc., which is the Canadian subsidiary of the Work Zone Safety Group. Joining me today are Tim Menard, Natalie Zapke, Bobby Lee, and Dustin Harbour from the LYT. I'm going to let the LYT team take a few minutes to introduce themselves. Start with Tim.
Hi, good morning, everybody. My name is Tim Menard, and I'm the founder and CEO.
Hey, good morning. I'm Bobby Lee. I'm Director of Marketing for LYT.
Good morning. I'm Natalie Zapke, and I'm the Regional Sales Manager / North American Channel Sales Leader for LYT.
Good morning, everybody. I am Dustin Harbour, the CTO of LYT.
Thank you. All right, let's get into the presentation. We're going to start with the state of the industry, and Tim's going to kick off that part.
Excellent. Thanks, Sherry. So to get started here, let's talk about kind of how things started. And for those of you who might be seeing this for the first time, or maybe you've seen this plenty of times, emergency vehicle preemption is a rather old concept now. It's had detection hardware since 1960 with the original 3M Opticom solution, which was a emitter-based device, which is kind of essentially like a flashlight on a fire truck, waving at a traffic light, trying to tell it, hey, I'm an emergency vehicle, and I need to move through this intersection safely. Can you please turn green for me? And for the time, that was a really good novel approach, because this was kind of the first time any type of vehicle was able to make a operational difference right at the traffic light. Next slide. And so when transit saw that emergency vehicles were getting green lights, they wanted to know if they could also be prioritized, but to maybe a little bit lesser extent, as we want to be able to move these higher occupancy vehicles, reduce the amount of single occupant vehicles on the road, and try to get more buses timely along the roads, since they don't have any ability to control traffic. So what we saw was an offshoot of emergency vehicle preemption and transit signal priority, which was using the same technology concept, but then wound up being a least aggressive setup, so that it would not completely preempt and disrupt all the other signals. Next slide. So the move from these two original systems that we're going to talk about today is that we want to make sure we all have a good understanding of what a computer-aided dispatch system is. It is a software system that is used by emergency services or used from transit, and it helps them keep track of fleet vehicles and what they're being dispatched to and what they're doing. It can contain a lot of additional operational and meta information that allows them to do their daily functions of operating their services. And a part of a computer-aided dispatch system is the automatic vehicle location part of it. And together, they really inform any agency of what's going on at any point in time so that they can dispatch a fire truck to the nearest scene, or they can make sure that when one bus finishes a route and it needs to be on schedule for another, they can dispatch the closest vehicle to be there. Since everything is a service to the public, it's highly time dependent and required to get everybody together. Next slide. So the reason why that is important to define those two concepts here is because the original technology that we were talking about of being an optical emitter on a vehicle that is flashing at some sort of detector that's on a signal mast at an intersection is because of the original way only was just a simple detection unit. And it only knew based on kind of the color of light or an encoding that was in it as to, hey, was this a fire truck or is this a bus? And that's really all it knew. And fire really is just emergency service vehicle. It could have been police, fire, ambulance, or it could have been light rail and bus. And so the origins of this system required a lot of maintenance. It was very prone to environmental challenges. Since the technology was essentially the same as what you have in your TV remote control, it can be very challenging on the road to get the light to change, just as it is if you're in the wrong location of your living room. Next slide. So the challenges that presented itself with the original hardware solution really became present over the next few decades. And as other systems came live, their new solutions were being looked at on how to kind of remove the pains that were in the first system. So we saw the advancement of GPS-based systems that had direct radio communication. So here, instead of telling the traffic light by using a strobe light, we were using direct communication, whether it be Wi-Fi or radio. We were using that to transmit longer distances. And now that helped because we were able to no longer have some of the line of sight challenges, and it could go a little bit farther away and was a little bit more dependable. But then we subbed it for GPS. And now with the GPS, the early GPSs, as we all may remember, were a little prone to GPS drift or a little bit of lag. And so what we also saw was, well, if we can use a GPS that's based on a vehicle, can we use a central solution approach where we have advanced traffic management systems that are already connected to our traffic lights? Can we bring this vehicle data in and do something with it there? And we'll get more into that. Next slide. So before diving really into the weeds now of the systems that we've had available and what we can do today, we want to take a moment here to look back at the high level, which is why cloud technology is really interesting and how all of the technology we're going to talk about today has matured over the last 10 years, and it's super significant. So in the cloud, effectively, or even just in our computers that we're all on today, these computers have got significant more resources and computational power than the small microprocessors that we run at the intersection in our traffic cabinets and traffic control units. It's an amazing factor just on a processor-to-processor basis. A simple comparison is you're looking at 25 times more powerful in your laptop and 192 times more powerful in the cloud. And that's truly significant because what this allows us to do, next slide. What this allows us to do, and by us I mean an industry, by using cloud, is that this opens up a new world of being able to get information such as weather, vehicle, use other types of algorithms or sophistication, computation that would be very expensive to put at the traffic controller level. And we're seeing that today in other products that do machine vision, machine learning. So one of the one of the real advantages here to kind of building out what is our next infrastructure look like in traffic management, and why is the cloud kind of really interesting and important, is because it's really a connector between all of our different private and public sector agencies to put kind of all data into one place where we can then use it together to solve the challenges that are happening on the road with more clarity and better understanding. Next slide. So why this wraps together nicely on how we left off on going to a centralized preemption solution was because the industry was looking for, how do we get rid of the hardware maintenance that's on the road and clean up our ability to provide citywide services to emergency services or transit services. But what we got in exchange was we traded out a hardware nightmare for an IT nightmare. And so that made things kind of difficult because you kind of lost the freedom to change. And what cloud preemption allows us to do is reopen up the ability to be interoperable at all levels though. So interoperable with your traffic control equipment, interoperable with the dispatch and operation systems that are at emergency services or transit, and be able to generalize that connection between everybody's back office setups so that data sharing can be done very easily with little time setup and extremely reduced budget needs. So next slide. And so the advantage of this really starts to unfold very quickly, because looking just from the emergency side, when you connect to the operation dispatch center, you're immediately able to see all emergencies, what the threat level is, where it's at, why it's happening. And then you can match that with state-of-the-art algorithms that are used for vehicle tracking. So LYT has got a background in connected vehicles from automotive and using vehicle data. So we've been able to move away from and use the lessons learned from prior attempts of using GPS data to not just rely on single point data, but to look at the entire whole. Where am I going? Where have I been? Where am I forecasted to go? So that you have a system that is matching the roads, knows the incident level, and is able to report so that the traffic system, our signaling system, can make the correct responses, delay the amount of traffic that's required if needed to in a dire situation, and then get back to operations very quickly. Next slide. So as we talked about in the earlier slides, anybody who worked with an IR system and then went to a GPS system probably has seen something like this in their community before, where you've taken your detection zone that used to be geometrically based on the road and turned it into a geospatial zone on essentially a Google map, where you try to define a business rule that if your vehicle's within the box, change the light, and if it's out of the box, do nothing or turn off. The challenges here of these systems is, although when set up correctly and well calibrated, can work well for emergency vehicle systems, the truth is when it gets sent to transit systems, it can be a nightmare. The reason being is what you don't see in this picture when you move the boxes away is all the bus stops that have dramatic effects on how the pre-programmed and set up settings get drastically affected. Next slide. So the reason why I bring that up is because of this is where machine learning is used very heavily in our system. Artificial intelligence machine learning is a process of being able to use real data from the environment, let computers analyze it and teach itself, and build its own code from experience, not through explicit programming. This is extremely important because what this allows us to do is be able to give information from the dispatch system, the operation system, and the location system to be able to identify what's happening on these routes. Next slide. Without going into a whole presentation on how we can apply machine learning, what happens here is that as a part of our system, we replace the part that used to be done traditionally of a traffic engineering survey where someone would have to either lay hoses, go up the clipboard, car count. What we're able to do today with today's systems that are already in place is be able to automatically, once we're connected, bring in all the agency information so we can build up a historic database of what has happened on the route that's being prioritized throughout the entire day. So much like an adaptive system that we've seen for all traffic management through cameras, here we're providing a dynamic adaptive system that is actually learning how people use each bus stop, why buses stop at them and when, and how traffic affects them, to build a prediction model of when vehicles will arrive at intersections so that we can take our bird's eye view approach that we saw in the earlier slides and now forecast to traffic signals that we don't need to detect when vehicles are coming. We know when vehicles are coming, and we know how to set the signaling system up to be ready for these vehicles to come. And when we live in a world where we can treat issues, there's a totally different ballpark. So we aim to provide arrival times 80, 90 seconds out, which allows a traffic signal, especially for transit signal, where you don't really want to disrupt the rest of the roadway for a bus, the ability to service everybody it can, put the bus through, and go back to normal operation with the least disruptive nature possible. Next slide.
So at this time, we thought it would be interesting just to see what percentage of our audience currently is using EVP or TSP. So we're going to do a poll. So if everyone can just click on which one applies to you. So are you currently using EVP and or TSP? How's it looking, Sam? Have we got people clicking on it?
We do have people clicking on it. I'll just give a few more seconds and then I will show the results.
Perfect. So we do have a range of people that are using both EVP and TSP, but we have almost as many that don't have any, are not using it at all. Thank you very much. Appreciate the input. So we'll move on to LYT's approach to EVP and TSP.
All right, thank you very much. Hello, it's Bobby again, Director of Marketing here at LYT. And just to dovetail off of what Tim had talked about, here at LYT, we have a cloud-based software platform that uses a state-of-the-art connected vehicle and machine learning technologies that you just heard about to prioritize the flow of vehicles in a city and across a corridor. So the bottom line is, transit and emergency vehicles, they can enjoy shorter travel times, less congestion, and more reliability with our solutions. So again, what we're doing is we're taking the data that's available at all of those various sources on the roadway and elsewhere. We're actively managing those signal lights, and we're optimizing the traffic flow on our platform in the many various ways that we just talked about. Just to take a quick look at how our setup is when we come into a city. Again, we're cloud-based. We're 100% software-defined. Our algorithms are continuously learning, and we have real-time reporting as well as flexible applications. So you can see here, whether you're an ambulance, a bus, a fire truck, we're communicating that information, or they're communicating that information through our cloud, and we're sending requests back in through the city's network through those network controllers. So we integrate with existing CAD and AVL systems as well as network traffic signals. We don't require, with our EVP and TSP solutions, we don't require any additional hardware to mount in the vehicles and no additional field or roadside hardware, just one edge device needed in your agency center. And because of that, we're able to launch in just a few days or a few weeks, and not months and years a lot of other solutions require. So I'm going to turn it over now back to Natalie, who's going to talk a little bit about our application of our emergency vehicle preemption solution in one of our cities. Natalie?
All right, thanks, Bobby. So this is Natalie again, channel sales leader here at LYT. So right now I'm going to share with you the details of a LYT EVP pilot deployment where our cloud-based technology was able to solve a long-standing congestion issue in the process. This is a case study for Rancho Cordova. Rancho Cordova is located just east of Sacramento, California. We installed LYT.emergency in 27 intersections along Sunrise Boulevard. The north-south corridor circles and Coloma Road, the east-west corridor circles, and in 6 fire vehicles. Some intersections had a legacy optical EVP system installed, but most had no EVP system in place. That is one of the beauties of our system LYT, is that it can ride on top of those legacy systems. So Sunrise Boulevard in particular was a heavily congested cut-through corridor in Rancho Cordova, connecting 2 highways on either side of town. Although Sunrise Boulevard had a speed limit of 45 miles per hour and Coloma Road had a speed limit of 40 miles per hour, the highest level of congestion precluded most vehicles from ever reaching those speeds. In fact, the congestion was so bad that the town had to send out their engineers every afternoon to manually turn intersection lights green to flush the roadway so that emergency vehicles would have a chance to get through that part of town. The Sunrise Flush, as it was called, was so unique that the U.S. Federal Highway Administration commissioned a study on it. The focus area of the flush is contained in the blue oval. Next slide, please. LYT was able to deploy our EVP solution in just 6 weeks. We started in September of 2021 with signal database programming and fire department systems integration. Just a few weeks later, we entered into the field testing phase with the city and county staff. And by the 3rd week of October, we were live. Next slide. The city of Rancho Cordova and Sacramento Metro Fire Department had 3 goals in mind for this. They wanted safer passage for their vehicles through intersections. They wanted to flush vehicles in compacted areas. And they wanted their installed EVP solution to account for pedestrian clearances during preemption situations. LYT was able to achieve all of those goals with our cloud-based EVP solution. Next slide, please. So coming out of the pilot, we were able to calculate the huge impact we had on these corridors. For the highest speed vehicles, those in the 90th percentile of speeds, we were able to increase their average speeds from 47 to 51 miles per hour, which was about a 7.8% increase. For the lowest speed vehicles, those in the 10th percentile of speeds, we were able to increase their average speeds from 13 to 22 miles per hour, a 69.2% increase, making a much bigger impact. Between signals along each corridor, we were able to reduce average travel times by 14.8%. And for Code 3 incidents, these are the incidents that are priority calls with the lights and sirens on. We were able to decrease average overall travel times by 42 seconds. As you know, in an emergency, that's often the amount of time between life and death. Next slide. Lastly, I wanted to show you a quick chart about the main corridor in that federal study I mentioned earlier, Sunrise Boulevard at Highway 50. This is a box and whiskers chart. The purple box represents speed performance after LYT's installation. The red box shows before LYT, and each of these data sets are separated by time of day ranges. Across every time range, you can see that LYT's cloud-based EVP solution was able to provide more reliable traveling speeds through each intersection. That means these fire vehicles did not need to slow down as dramatically as before, contributing to faster travel times to incidents. And most importantly, thanks to the performance improvement LYT's EVP solution provided to the city of Rancho Cordova and Sacramento Metro Fire Department, the city was able to stop performing that sunrise flush every day. To give you a visual illustration of how much faster and more consistently these fire vehicles were able to travel, I want to show you a before and after video. Bobby, would you mind playing that video for me, please?
Okay, are you able to see the video?
It's not. Oh, now it's going, I think. Here. Okay. So the before video here is playing. We sped up this video for brevity's sake, but as you can see here, the fire truck is slowing down at every intersection, contending with congestion and poorly timed preempted green lights. Excuse me. Let that keep going here. The nice thing about our platform too is that you can actually see, get more analytics on the truck even, as you can see the cursor over it. So next we'll go to the after video. Bobby will pull that up for us. All right, so this is after. So now in the after video, you can see the fire truck leave the station and immediately receive green lights. This fire truck is moving at consistent speeds because we're providing perfectly timed ETA-based green lights. If you take a look at the speed indicator in the dialog box showing speeds almost double that from the video before. That's the power of LYT's cloud-based approach to EVP. Let's keep going here. It looks like they made it to the scene. Just about. All right, so next, I'd like to turn this back over to Bobby, and he's going to take a look at one of LYT's TSP case studies.
Hello again. Thanks, Natalie. Yeah, I'm going to talk about how we applied our technology in transit signal priority. And this is in the city of San Jose in California, in the Bay Area. And the section you're looking at right here is Route 77. This is the Valley Transportation Authority. And this particular area of San Jose is in East San Jose. It's a mixed income, very transit dependent neighborhood with a lot of negative health outcomes happening in this community. We were in about 20 or so intersections here and a few you can't see beyond. But there are a lot of really interesting challenges present along this 5 or 6 mile corridor here. You've got intersecting intersections that have adaptive timing, coordinated timing. You had a fire station in the middle there. A lot of things that we had to contend with operationally to make sure that we're not disrupting other existing solutions along that roadway. So to back up here and to go back to a little bit what Tim was talking about earlier about machine learning, this is where we're able to take that technology and really apply it into the real world. So this is, again, Route 77. What you're seeing on the green line, this is the normal path of travel for that bus. And the white dots are the bus stops. So as you can imagine, it's trudging along, it's stopping, making those stops, going along, making the stops. The orange line represents the speed of that bus. So it's slowing down at the intersection, slowing down at the bus stop, it's picking back up to the next bus stop, and it's slowing down again as it approaches the next intersection. The purple line indicates the vectorized time arrivals. That's the ETA-based arrival that we were talking about earlier. And it's calculated based on the vehicle speed and that bus stop dwell time. And that's where the machine learning really comes into play here, is we can estimate that timing and to provide accurate and perfectly timed green lights for that bus. So what are the benefits? What are the other benefits of machine learning on Route 77? Well, we looked at the before baseline data before LYT was put into place, and then we crunched 2 additional months of data afterwards to train the algorithm through machine learning principles. With our ETA-based TSP solution, again, we easily accounted for those nearsighted stops, the dwell times for things like wheelchair boardings, and many more events that were happening on that roadway. If you had an optical or GPS-based TSP solution, it would simply trigger that green light when entering a detection zone. So a much different and also a much more consequential approach to TSP. Our engineers optimized our TSP for those roadway conditions and updated the algorithm and training on the fly remotely. And so by creating the digital twin that you saw in that video for our EVP deployment, that digital twin on the corridor here in San Jose lives in our LYT portal, and we were able to test, iterate, update, and improve our algorithms and our estimations without any agency intervention. And in fact, oftentimes we were actually informing the agency of anomalies that we're seeing on the roadway and in the data before they saw it. So things like communication errors with their signals. Ultimately, we, through LYT.transit's implementation on Route 77, we were able to shorten travel times for that bus by 20%. The agency enjoyed a 14% fuel savings on that route, which we calculated out to be about 3,300 gallons of diesel fuel for that one particular route annually. There was a 12% reduction in emissions, and as I mentioned, this is a transit-dependent neighborhood with a lot of negative health outcomes. Reducing emissions by 12%, particularly from diesel buses, absolutely astounding and very, very impactful. And most importantly, no added field hardware needed to get this implementation going. So again, to reiterate, there were no modifications made to the roads or the routes. There were no red carpet lanes. There were no additional hardware in the field. We removed about $2 million from the cost of the project compared to a traditional TSP implementation, and about 1,800 hours of installation time that was removed by installing LYT versus other TSP solutions, traditional and legacy solutions that are on the market. I want to transition a little bit into, I know we're running a little bit short on time, so I wanted to show a little bit of our portal. As you saw earlier, any agency can log in, any of the employees authorized at the agency can log in and take a look at their city. We're going to put all of the traffic signals and the fleet on the portal so that the customer can see in real time their performance, if it's TSP, or to watch their vehicles move through their town. I want to zoom in a little bit and look at an intersection. We are able to communicate out the status of those sensors, the phasing that the signal is in. So for example, in this situation, there's red and green lights showing which side of the intersection is receiving a red or green light, as well as the white circles indicating whether a vehicle is on that sensor or a pedestrian has activated the call button at the intersection. We also provide a lot of analytics available to the agency as well. So in this case, in this particular intersection of Rancho Cordova, what you're seeing here is our preemption request happening. So going back to EVP, you're going to be looking at the preemption channel at the top, the time in each of those phases, and in particular with the flags here, label flags here, you're going to be able to see when we sent a preempt request, when the signal turned on the preemption, when the vehicle arrived at the signal up in phase 6, and then when LYT turned off the preemption request or sent an off request, and then the signal turned off the preemption. So you can track this both historically and live in every one of those connected intersections on our platform. We're also going to provide to you things like what percentage of time your intersection spent in each of those phases, as well as the ability to export and save that data. On the TSP side, we're also going to be able to show you things like how many TSP calls were made over a certain time period, a customizable time period, in this case, last week, and the percentage of success. So you yourself can really be able to audit and see how successful your TSP strategy has been performing. So with that, I'll turn it back over to Sherry, who has a quiz question.
Thanks, Bobby. Appreciate that. So as we've done in all of our webinars up to now, we do have a quiz question just to check and see if everybody's listening. So let's go ahead with that. You can put your answers in the question feature, and Sam will let us know the first correct answer that comes up. You need to click the thanks. Do we have any responses yet?
We do. So the first person to answer correctly was Tyler. He answered B, which is the correct answer. I will contact you afterwards to get your address so that we can send you our goodie prize package.
Thanks, Tyler. We'll move on to the next slide. So as usual, we have another webinar coming up. So we like to just take a few minutes and let everybody know that the next webinar is on August 3rd at 1 p.m. Eastern. Michelle Mondor will be discussing 2 of TAPCO's intelligent warning systems, the flood warning system and the overhead detection system. So please join Michelle and TAPCO and he will let us know more about how these systems can save time, money, and lives. So now we want to move on to questions and answers. Please use the question feature to ask any questions. Sam will read them out so that everybody can see them. We also have Dustin here, the CTO for LYT. So if we have any real technical questions, Dustin's going to be here to answer those.
So we do have a question. Someone asked, was the 42-second decrease in travel time along the entire corridor? And do you have an idea of travel time decrease per intersection?
Sure, yeah, I can answer those questions. So the first one, we measured a 42-second decrease in incident response time. So it wasn't necessarily along a corridor, although many of those incidents did pass through a significant amount of the corridor. And then the second question in terms of speeds at individual intersections, we do have that measured. I don't have specific stats around just intersection time alone, but we did see a substantial increase in vehicle speeds at the lower end of the vehicle travel time spectrum. So the bottom 10% of vehicle speeds, we saw almost 70% increase from, I believe, 13 miles an hour to 21 miles an hour. So we saw substantial gains in the places where it makes sense that the vehicle would slow down, which is great.
Someone asked, are we able to show the slide deck? Yes, we are. We'll send out the slide deck and a recording of the webinar to everyone tomorrow. And then those look like the only questions so far. We'll wait a few seconds just in case anyone's typing.
I would like to add too that if anyone would be interested in a live demo or kind of seeing particularly what we can do for your city or your region, please reach out to Sherry and we can absolutely do a personalized demo for you.
A few more questions have shown up. So someone asked, was the EVP corridor chosen based on congestion alone or accessibility / distance from stations?
It was definitely more of the latter. We really wanted to capture instances that were close to the station and really get that first part of the journey improved by having a higher chance of being able to come across incidents starting from the station. So that's why we chose those 2 corridors. And on Coloma Road, there was a fire station in the middle of the corridor, and then on Sunrise Boulevard, the station was to the north. And so since so many incidents happen along Sunrise, for that station at the northeast side of the city, it made sense to choose Sunrise as the corridor, in addition to the known congestion issues that were observed by the city and the county.
Someone asked, how do you register for our next webinar? There will also be a link in the email that gets sent tomorrow. And that's it for questions so far. If you have any questions that pop into your head afterwards, we are going to have our contact information after the slide. So feel free to reach out and we can go into more detail.
So I'd like
so
to...
Sherry, if I could. Yep. Hey everyone, this is Tim again. Just wanted to also re-highlight and share in some of the questions, kind of a common theme, is that one of the roads that was chosen as well had no preemption equipment whatsoever, and the city was, from the city side, they were very interested in seeing the technology work on a section of road that had never had any treatment whatsoever before. So there were significant gains found there, just because it literally went from nothing to something. And then at the other intersections where we had different preemption technology and strategies, as Dustin had shown in his slides, and we'd be happy to go through in more depth with anybody who would like to see more. We did look by the intersection as to what was the before and after of intersections that didn't have preemption on that Sunrise Boulevard, what did have IR, how that differed, and really not only how did the speed change, but how constant was that ability. So a lot of our data that we were able to see in some of those graphs, the real takeaway to look at is not only did the speed increase and safety was improved, but it was actually a much tighter band as well, which means it was very repeatable. And drivers actually noticed this and responded back saying they noticed a huge difference with the system. They noticed exactly the moment it was turned off. The community noticed, and that was a huge kind of result that one we kind of anticipated because we knew there'd be such a huge difference. But that's really what is striking here is it's really about getting the infrastructure to be reliable every single time and taking out second guessing as to, oh, do I really have preemption? Is this like really going to change for me? And making sure that at the end of the day, the driver of each one of these response vehicles has got the confidence to roll through each intersection without any conflict from another vulnerable road user.
There was one more question that came in. Someone asked, does the intersection and EV both need sensors for preemption?
No, that's the beautiful part of our system. There's no field equipment whatsoever, and everything is done via the AVL from the vehicle and the dispatch data from our dispatch data provider, and then our cloud system.
So it is time for us to wrap up.
So I'd like to thank Tim, Natalie, Bobby, and Dustin for their help with the presentation today. I'd like to thank everybody who joined us to learn a little bit more about the LYT solutions. As Sam said, we'll be sending out a link for the recording of this webinar, as well as we'll be sending out information to register for the next webinar. Please reach out to Stinson ITS if you have any additional questions to myself, or if you know your account manager, if you're based out of Ontario or Quebec, please reach out to them. We'd love to schedule a meeting for a live demo and discuss your specific preemption needs or transit signal priority needs. You can also visit the LYT website for additional information. So again, thank you everybody for joining today, and look forward to seeing you at our next meeting, our next webinar.
Thanks, everybody.
Thank you.
Thank you.